Hello, my name's Thomas Chlaupek.
My name's Fraraccio.
My name's Shane Fairbrother.
Dan Cross.
Taylor Fortier.
And this is our MCE201 suspension project. We made the double wishbone A-arm suspension.
So for our research, we looked into the McPherson strut. This is a popular suspension system in small cars. It's a very simple suspension system in that it only has a lower control arm. That's in contrast to the double wishbone suspension system, which has two. And so that makes it very economical in terms of the amount of materials it uses, its weight. It's also very narrow. The negative aspects of it is that it tends to be taller. So the cars that use it have to have a higher hood line, and it's got limited camber gain.
The next part of our research that we're going to be talking about is the leaf spring suspension system. This system uses several layers of metal called leaves as the spring in a suspension system. This system is very rigid, so it's most commonly seen on heavy-duty vehicles, but Corvettes have used them since the 1950s. Unfortunately, because the Corvette is a lighter car, it wasn't as successful in the spring component of the suspension system, but instead was utilized as an anti-roll bar. This system is called the Traverse leaf spring suspension system, and it basically utilizes the pros of a leaf spring suspension as well as other suspension systems that would have more range of motion. In the Traverse leaf spring suspension system, by placing the leaf spring along the width of the car horizontally, the stiffness allows it to work well as a great anti-roll bar but still utilizing the upper control arm and the spring with greater range of motion for uneven terrain.
So our research for the double wishbone A-arm suspension system with unequal length arms, we found that it controls many parameters for the suspension system, such as camber angle, which is the angle that the tire forms with the road, so it's not perpendicular. The caster angle, which is more the vertical angle, toe pattern, roll center height, scrub radius, and scruff. Also, it's been used for many years in race cars, sports cars, and also everyday sedans. It almost always keeps the tires perpendicular to the road, which is very important. And it uses the unequal length wishbones to reduce tire rubbing, which equal length wishbones produce a lot in excess of tire rubbing. So in order to produce less, we use the unequal length wishbones. The design's costly. It takes up a lot of space behind the rear wheels, so it's not the most economical suspension system to use on a car, but it is very, very good in reducing tire rubbing and producing a negative camber angle. It's mostly used on American cars, and one exception to this would be the Honda Civic. Uses this suspension system as well. Alright, so now I'll be talking about the Mini Baja team's current suspension system. Currently they use an equal arm suspension system for the rear suspension of their vehicle. The design currently produces just a slight amount of negative camber, and this is not optimal for the vehicle because for the most part, when going over obstacles, you lose a lot of handling and traction due to the wheels not having a lot of movement and not making optimal contacts with the surface. Also, the reason their design was used was because the team ran out of time last year while producing the vehicle from scratch. And down here you can see a small picture of the equal arms on both sides for the rear suspension, and they're the same exact length, which produces basically that perfectly perpendicular suspension with the tires there.
So the design we were thinking of for our suspension system is an unequal length double wishbone. And so in this suspension system, the top wishbone is shorter than the bottom wishbone. And this leads to a better camber gain compared to the equal length suspension system that the Mini Baja team currently has. Particularly in regards to turning, for the unequal length wishbone suspension system, the wheel tends to stay more perpendicular to the road than equal length arms, and so you'll wind up with more stability and control, especially on uneven terrain, which is common in the Baja courses. So we think this is a good design that really improves the Baja team's current design, particularly in regards to camber.
Next, I'm going to talk to you about the rapid prototyping that we chose to do for the suspension system. We chose the bracket from the suspension system, which attaches to the chassis, and a pin is pushed through, which allows the suspension system to go up and down and rotate when it goes over uneven terrain. In doing so, we had to transfer a SolidWorks file over to an STL file and use that to print using the 3D printer. We had to center the piece at the bottom of the origin so that there'd be no space in between the ground and the object we were choosing to print. We used a 2-to-1 ratio, and the process took 30 minutes to complete.
So I'm going to be talking about the actual design on SolidWorks of the suspension. So what we did was we used the given step files from the Mini Baja team to get an idea of what we want to do. So we looked at their design and figured out what we wanted to do was the double wishbone. So we used measurements taken from the actual back of the Baja team and from the step files using like Smart Dimension and all. And we brought in the correct widths of the unequal lengths. So the bottom is longer than the top, the bottom, to allow that correct camber when going over the uneven terrain. So, like I said, we use the references from the step files to make the correct dimensions and all of the actual our design. Everything's completely symmetrical. So as you can see, there's only the rear left viewing of the suspension. But if you were just to mirror it across the other side, it'd be incredibly symmetrical. And then the spring, as you can see here, is the attachment point to the higher part of your actual rear of the Baja. And when compressed and extension, it'll have the unequal ride heights to allow the actual car to remain very high contact points with the road at all times as it travels through the course of the Baja.
Our suspension system produced a large amount of negative camber. You can see from this picture right here. It helped maintain traction around cornering, and we were able to get this negative camber by having a shorter upper wishbone than the bottom wishbone. You can see from this video the negative camber. And as you could tell, it was able to maintain that negative camber through the whole motion of the suspension. This is our bill of sales. It's a list of all the parts that we used for our suspension system. We have the drivetrain cradle, which is the frame that the suspension actually connects to. We have a mock hub, which is what connects the wheel to the suspension system. We have all the pins for the brackets, which is just with a point of rotation for the system. A control arm tab, which is the bracket that connects the system all together. And we have a spring, the bottom wishbone and the top wishbone, which is just the bottom and the upper portion of the system itself. The bolt clamp, which allows the wishbone to connect to the bracket. The spring pin, which is another point of rotation for the spring. The spring bracket, which connects the spring itself to the whole suspension system. And the wheel.
So in the end, it was concluded that the most efficient suspension for the task would be the double wishbone with uneven lengths. With this suspension design, you're given the most contact with the road surface as the wheel travels up and down terrains of motion, and a very wide one at that, since the Baja has very uneven terrain, and also a lot of turning, which will help with the correct camber design. It also has a lot of weaknesses, unfortunately. Since it is a very complex suspension design, it's very expensive compared to other options the team would have, especially the one they had the year prior. And that's another reason why they didn't establish some kind of suspension similar to this one for this year, because of the fact they ran out of money since they had to build the car completely from scratch. It's also hard to service since the wishbone design is very complex. It's hard to get behind the wheel and access all the points needed to be changed or repaired throughout the life of the suspension system.
In the end, we hope you enjoyed our suspension system. Have a happy holiday.